All right, let's take a look at question 1 here. The amount of time t, so we have the variable t, that it takes to complete a task varies inversely with the number of workers w. So we are going to do the t1 times w1 equals time 2 times w2. So then let's just plug in our numbers as we're reading the problem here. If it takes 8 workers, so that's my workers 1, will go under there, the W1. 10 hours, so 10 will go under time 1. How many hours, so we're solving for T2 on the other side, will it take if we have 4 workers? So now let's reduce this down a little bit here, give it some space. So if I look on the left-hand side right here, 10 times 8, that's 80, so I have 80 equals, and then T times 4 is the same as 4T. So 4 times what is 80? That's easy. It's just time is 20. So it would take 20 hours. All right. Question 2. Solve this. Looks like a very complex rational equation, but it's not, because if you look at the very bottom, each one of these fractions, the denominators, are all the same. If all of the denominators are the same, you can cross them out. You can say, okay, goodbye. And we're just left with b plus 1 plus b minus 8 equals b minus 1. Then we're simply just going to combine like terms on the left. So we're going to put our b's together. B plus b is 2b. And then we do 1 minus 8 is negative 7. And that is equal to b minus 1. Now what we want to do is we want to get letters on one side and numbers on the other. Let's move this b over here to the left. So since this b is positive, we're going to do the opposite. We're going to subtract it. So then I do 2b minus 1b is just b, just 1b. And then bring down the negative 1. So now that we have variables on the left, the letter on the left, we're going to move the negative 7 to the right. So the opposite of minus 7 is plus 7. And then we just say b equals 6, and that is our answer. So how would you solve that using Desmos? So let's fire up Desmos here. And I'll show you how to do this the graphing way. Now anytime you're graphing in Desmos, you want to make sure that you are using the letter x and not the letter b. So we're going to do parentheses x plus 1 divided by x plus 5. That's our denominator, right? X plus 5, and then jump over to the right, and then we go plus, and then we have x minus 8, x minus 8. Oops. Let's put our parentheses here. X minus 8 divided by x plus 5. So we type the left side of this equation right here, typing the left side in box 1 or input box 1. Just pretend like that top one is not there, the 2 times the square root of x minus 7. Pretend like that's gone. I have it unselected, so it's not being graphed. Then we're going to type in this guy right here in box 2. So we're going to go x minus 1 divided by x plus 5, and then we are looking for the intersection. So where the 2 lines intersect is right here, and we're only looking for the x coordinate. And if you look right there, you see the x value is 6. So anytime you're solving an equation, you can do the left side in box 1, the right side in box 2, calculate the intersection, and we only need the x value. All right, let's take a look at 3. Given the problem, 1 over x minus 5 equals 12, what can x not equal? So in this case, it's saying, in other words, what value of x makes the denominator equal to 0? So if I have x minus 5 equal to 0, well, I know that if I plug in a 5 right here for x, I get 5 minus 5 equals 0. And you cannot do 1 divided by 0 because that is undefined. So our answer would be x cannot equal 5, because if it does, it makes this part right here 0, and that whole problem would be undefined. All right, let's move on. Let's go to number 4. Solve this equation here. Now, we've done this type before. This is a very complex way I'm going to show you the way that I solve these here. And then, of course, you know the graphing method. So let's do the graphing method first. We're just going to, in fact, let's only do the graphing method here. We're going to type this guy here on the left into input box 1, and then we're going to type in 3 into input box 2. So I have everybody unselected. I'm just going to leave those there. So 4 divided by x plus 1 plus, we'll go 6 divided by x minus 2. And then we type in 3 in the box. And well, when I type in 3 and I press enter, nothing shows up. I'm not getting a line. So you actually have to type in y equals 3. There we go. And if you look right here, we're getting 2 intersections. So I have an answer of negative 0.288. And I have an intersection of 4.622. And I'm showing you the graphing method here because in one of my videos on my channel, I've already shown you guys how to do this problem, the paper method. So if you go back to the channel and you want to see the paper method, this exact problem is done. It's in your foldable, and it's going to be under how to solve rationals with unlike denominators. But in this case here, you guys are probably going to fire up the calculator and just do the left side in one box, the right side in the second box, and we're only looking for the x values, so this would be my answer, or these would be my answer. All right. Let's move on. Let's look at 5. Simplify the expression below. We are taking the square root. So in your foldable, you have a list of perfect square roots, like the square root of 4 is 2. The square root of 9 is 3. And we're using the positive values of the square roots. So then you have to figure out, where does 48 go? Well, 48 would be between the square root of 49 and below, right? So then I have to figure out what perfect square root number, the biggest perfect square root number that goes into 48. Well, that would be 16. So we're just going to say 16 times 3, and then we have x to the 6th, y to the 9th. And our rule is we're going to take the square root of 16, so we're going to extract that. That is going to be 4. And then we'll draw our house right here. The 3 stays on the inside. Then we just simply divide by 2. Since we're taking the square root, we divide the exponents by 2. Well, 6 divided by 2 for the x is x to the 3rd. Well, 9 divided by 2 is 4.5. So how many times does 2 go into 9? The most that it goes into it perfectly without a remainder would be 4. 4 times 2 is 8, and then that means we have a remainder of 1, and this would be your answer. What are the coordinates? Number 6, what are the coordinates for the vertex of this particular equation here, this function? All right, let's graph that in Desmos. I already have it in my input box 1. And the vertex is simply where this particular graph starts. Well, you can see right here that the vertex is a very easy question. It's at 7, 0. If it were a quadratic, it would be either the highest point or the lowest point, but since this is a square root, it shoots off to the right. My vertex is at 7, 0. It's where the graph begins, where it's born. All right, let's talk about domain and range. So domain is going to be how far to the left and right the graph travels. This is our domain. And our range is going to be how far up and down the graph travels. And so let's take a look at what we have here. Right? And so if I were to, let's do this here. Let's take a screenshot of that. Maybe. And let's mark up on this here. There we go. So if I were to box this out here, let's see if it's going to work. Give me something. Let's do a highlighter here. If I were to box this out, right, we're only going to go down here, and then we can't box it up here because there's an arrow. So remember, domain is how far left and right the graph travels. It starts here at 7, and then it goes to the right forever. So that's infinity. 7 is part of the graph, so it gets a bracket, and you can never capture infinity. So that means that infinity gets a parenthesis. Now this is range. Range is how far up and down the graph travels. Well, how low does the graph go in the y? It starts at 0, and it goes all the way up to infinity. So how do you write your range? Your range would be start at 0 and go up to infinity forever. So that would be our answer for domain and range here. So we said our domain is, it's starting at 7 on the x-axis. That doesn't look like a 7, come on. And go to the right forever. Then we're looking at how far up or down the graph travels. We start at 0 on the y, it's part of the graph, and it goes up forever. Number 8, find the inverse. So the rule for the inverse is we're just going to simply write it as y equals the cubed root of x minus 5 and then minus 8 on the outside. And we are going to switch x and y. So we say x equals the cubed root of y minus 5 and then minus 8. And so this problem is pretty simple. So if negative 5 is on the inside of the house, that means at the very end it needs to be on the outside of the new house. If minus 8 is outside of the house, that means positive 8 needs to be on the inside of the house. So you're going to either change the signs, well, you are going to change the signs, and then simply just put them either in or outside of the house, reversing where they're at. And the opposite of cube root is cubing to the third power. And that doesn't look like that, but to the third power. So we could just simply go like this. We could say y equals, make your house, and then we go plus 8 on the inside, plus 5 on the outside. Or let's actually just solve this here. Let's see what we come up with if we just solve this. All right, let's move this down. So here we go. We're going to get the house by itself. That's the goal. So do the opposite of minus 8. We're going to plus 8 to the other side. And we are going to remove the cubed root. The opposite of cubed root is cubing. So I go to the third power. So then I have x plus 8 to the third power equals, the house goes away, and I'm left with y minus 5. We need to get y by itself. So we're just going to add 5 to the house on the other side. And if you look, it is the same thing we did right here. So you are changing the sign and either putting it in the house if it's not, or taking it out of the house if it is. Now you can do this the graphing method if they give you multiple choice. So let me show you what that looks like. I'll fire up Desmos here. Make sure everybody's deselected. So the first thing you want to do is, and I'm going to shrink this down a little bit here. Here we go. The first thing you want to do is graph something called the line of reflection, which is y equals x. Then we are going to graph our original. So you could type in f of x, or you could type in y equals. I'm just going to do y equals, and the cubed root is going to be at the very end here. The cubed root of x minus 5, jump out of the house, minus 8. Then we are going to type in our answer here. So we'll say y equals the cube root, the x plus 8 cubed plus 5. And what you're looking for is you're looking for a diagonal reflection. So if you look at the blue line and you look at the green line, you see how they're diagonally reflecting over the red line, which is y equals x. When you find the reflection, you have your answer. So you can put your problem in the first box, or you can put y equals x in the first box, graph that line of reflection, which is the red line, and then graph each answer choice until you see the reflection.